Hello everybody, welcome back to the second part of the network theorem. In this lesson, we're gonna solve a complex example. This example gonna explain more details on how to use the superposition theorem. So let's start with this example on the board. You can see here that this complex example has one current source, one voltage source, and these two are independent sources, and we have one current source and one voltage source, but these are dependent sources. So the question is asking to find the V over the 20 ohm resistor. So, as we explained before, when you are using superposition theorem, you have to remove one of the two sources. But I choose this example to show you that the removing sources is only the independent sources. So we can remove just these two sources. What about the dependent sources? You never ever gonna play with them. Okay, so let's start first by removing the current source and finding the voltage across the 20 ohm resistor. So I'm gonna remove the current source just like this. Remember, when you're removing the current source, you're gonna leave an open circuit there. So I'm gonna solve it using last method we have explained. I'm gonna use mesh analysis. So this is my first loop, and this is my second loop. Okay. So writing the KCL equations, but before that you have to put the signs on the resistor. So here plus, minus, this guy has greater value than this one, and that's it. These two resistors, the 10 ohm and the 20 ohm, is fixed sign. So fixed sign. Okay. So now the first loop, which is this one, is 10 volt minus 10 volt, the sign minus 5I1 minus 20 I1 minus I2, 20 I1 minus I2. Okay, all of that is equal to 0. Okay, all of that is equal to 0. Now you're gonna simplify this equation. 5 I1, 20 I1 plus 20 I2 is equal to 0. Now you have 10 25 I1 plus 20 I2 is equal to 0. So this is the first equation, right? Now, moving to the second loop, you can see here that you have a dependent current source, and you have the I2. So the I2 arrows is in clockwise direction, and this current is oppositing it. So I2 is equal to minus 0.4 VA. You're gonna look, where is VA? Here is VA. So what is the value of VA over the 10 ohm resistor? The value of VA is equal to 10 multiplying to I2, right? 10 multiplying to I2. Now, substituting this thing here, you will have I2 is equal to 0.4 10 I2. Okay. Now simple calculus, moving this in this side and so on, you can find that I2 is equal to 0 amps. Okay, 0 amps. Now you have the I2. Substitute it in the first equation. You will have 25 I1 is equal to 10. So I1 is equal to 10 over 25, okay? I1 is equal to 10 over 25 amps. After substituting the I2 in the first loop equation. That's how you solve the questions, okay? Now you have the I1, so I'm gonna record that by side, that I1 is equal to 10 over 25 amps. This is removed current source. Okay, this is the removed current source, which is this one. Now all you have to do is to substitute in the I1 in this part, okay, in this part, to find the voltage across the 20 ohm resistor. So after that, after finding the voltage across the 20 ohm resistor by removing the current source, you're gonna record that by side, okay? Then we move to the second part of the question, which is shorting the voltage source. Shorting the voltage source. So this is 5 amps. I think, yeah, it's 5 amps. Now all we have to do is shorting the current source. Okay, this is the short one. Okay, the same as before. We're gonna solve it using mesh analysis, but now we have 3 loops. 3 loops, 1, 2, and 3. Okay, I3. Now, from this loop, you have to know that I3 is equal to minus 5 amps. Okay, because the arrow is in clockwise direction, and the current is draining current in the opposite direction. Okay, good. Now, in moving to the first loop, we write the KVL equations. Where is that? Yeah. So it's minus 5 I1 minus 20 I1 minus I2. All of that is equal to 0. Okay? All of that is equal to 0 for this one. Now, the second loop, I2, but I2 is equal to minus 0.4 VA, minus 4 VA, because it's draining in opposite direction. Now, what is VA? As before, VA, which is this one, is equal to 10, okay, I2 minus I3. I2 minus I3. Remember, in the previous part, there was no current source here. There was no current source here, so it's just I2. But now we have a current source here, so it's I2 minus I3. Good. So substituting this here, so you have I2 is equal to minus 0.4, 10, I2 minus I3. Okay. Now I3 is equal to minus 5 amps. So I2 is equal, by substituting this here, so you have I2 is equal to minus 4 multiplying 10 to this, I2 plus 5, yeah, plus 5, no, plus 50, because, wait a second, yeah, multiplying this, okay. So it's minus 0.4, 10 I2 plus 50, okay, plus 50. Now I2 is equal to minus 4 I2 plus 50 multiplying to this one is equal to, I don't know, minus 0.4, 50. Okay, moving I2 to this side, you will have, moving I2 to this side, you will have I2 plus 4, which is 5 I2 is equal to minus 0.4 multiplying to 50 over 5 I2 is equal to minus 4 amps. Okay, minus 4 amps. Now you find the I2, you have I3, put them in the main equation, or just I2. Yeah, you don't need the I3. Just I2, put it in the first loop equation. You can find I1, which is the same as IA. After that, you can use the I1 to find the voltage across the 20 ohm resistor. After finding the 10 ohm, after finding the voltage across the 20 ohm resistor, you're gonna sum them together, which is the superposition. The voltage, the final result voltage is the two source affecting the resistor, this 20 ohm resistor. So that's it. This is one of the very complex example we have. I hope that you have understood it very well. I advise you to review this video a lot to get used on these examples, get sense of intuition about circuit, and that's it. Subscribe us on YouTube, leave a comment, share these videos with the first year colleagues, and hope you to enjoy this series. We will continue later. Thanks.